These are MCQ and 1 mark question from the lesson Coordination Chemistry based on the last year board exam question paper. The compound COSO4 NH3 5 times Br and CONH3 COBr NH3 5 times SO4 represent. Here we can see sulfate and Br get exchanged in the complexes. So the negative ligands gets exchanged. So this type of isomerism is known as ionization isomerism. The first case bromide ion is outside and second case sulfate ion is outside. Ionization isomerism. The oxidation state of iron in iron pentacarbonyl. Carbonyl is a neutral ligand, and when a metal is combining with the carbonyl ligand, metal will be in its lowest oxidation state. Here carbonyl is oxidation state is 0, so iron will be in 0 oxidation state because the sum will be equal to 0. The formula of the complex dichlorido bis-ethane 1,2-diamine platinum 4 nitrate. So dichlorido bis-ethane, bis means 2 times, ethane 1,2-diamine platinum. Then it is the oxidation state of platinum is given as 4. Then nitrate is given. Now platinum is in +4 oxidation state, 2 chlorine, 2 into -1, that is equal to -2. En is neutral. So the sum of oxidation state will be +2. So to balance it outside it should be -2. So NO3 is -1, 2 NO3 -2. So our option is B. What is the secondary valency of cobalt in COEn twice Cl2 plus? En is a didentate ligand, so 2 into 2 plus chlorine is unidentate, 2 chlorine, that is equal to 2. So 4 plus 2, that is equal to 6. So our secondary valency is 6. Which of the following ligand is an ambidentate ligand? We know ambidentate ligand has 2 donor atoms. Here CONO2 NH3H2O, NO2 is the ambidentate ligand. It has 2 connective sites, nitrogen as well as oxygen. So it's an ambidentate ligand. So our option is B. The formula of the complex iron 3-hexacyanidopherrate. So here iron 3-hexacyanidopherrate. So let us write the formula like this. Now for balancing, iron its oxidation state is given as +3 and here it is +2. So the sum of the oxidation state is +4. So when we crisscross, here we will get 4 and here we will get 3. So Fe4, FeCN6 thrice. So our option is B. How many ions are produced in the solution NiNH3 6 times Cl2? So when we break this, we will get the complex part will stay together. NiNH3 6 times. The charge of the complex is 2 plus and you will get +2 Cl minus. So the total number of moles, it is equal to 3. Which of the following is not expected to be a ligand? Carbonyl is a neutral ligand. Ammonium is not, ammonium ion, it's not a ligand because the lone pair of nitrogen is used by H plus for bonding with the ammonia. And water and NH3, they have two donor, one donor atom. Ammonia, nitrogen is the donor atom, and in water, oxygen is the donor atom. So our option is NH4 plus. Which of the following is most stable complex? We know compared to unidentate ligands, didentate or polydentate ligand form stable complexes. Here oxalate is a didentate ligand whereas CO, CnH2 all are unidentate ligands. So iron trioxalato iron 3 will form the stable complex. Which of the following is a chelate complex? Chelate complex is formed by didentate or polydentate ligands. Here En is a didentate ligand, so COEn thrice 3 plus is the chelate complex. Optical isomerism is not shown by. Generally cis compounds show optical isomerism and trans compound does not show optical isomerism because we can see the mirror image will be identical. In the first case, we can draw the structure like this, and when we draw the mirror image of this, the same mirror image you will get. So transform cannot show optical isomerism. So our option is A. Which of the following is a polydentate ligand? Ammonia is unidentate, ethane 1,2-diamine is didentate ligand, EDTA is a hexadentate ligand. So we can consider it as a polydentate ligand, and oxalate is didentate. Which of the following coordination compound exhibit linkage isomerism? So in order to show linkage isomerism, the complex should contain an ambidentate ligand. Here we have ammonia unidentate, ammonia carbonate, they are unidentate ligands. Then nitrito is there, it's an ambidentate ligand. So this complex will show linkage isomerism. CONH3 5 times NO3SO4. So here we can see two negative ligands, and in the second case nitrate is outside the square bracket. First case NO3 is inside the square bracket. So this type of complexes will show ionization isomerism. In which of the following does the central atom exhibit an oxidation state of +3? In the first complex, cyanide is in -1, so -4, and 2 potassium +2, so nickel will be in +2 oxidation state. In K4FeCN6, 6 cyanide -6 and 4 potassium +4, so iron will be in +2 oxidation state. In FeC2O4 thrice, oxalate is in -2 oxidation state, so 3 oxalate -6 plus 3 will give you -3. So iron will be in +3 oxidation state. Whereas in CuNH3 4 times 2 plus copper is in +2 oxidation state. What type of isomerism is shown by the following pair of complex compound? Here CuNH3 6 times, the coordination number is 6, and second complex also coordination number remains the same. And we can see the metal get exchanged. So this type of isomerism is known as coordination isomerism. In which of the following does the central atom exhibit an oxidation state of +4? In the first case, nickel shows an oxidation state of +2. Second case, copper shows an oxidation state of +2. In the third case, the sum will be 0, so platinum will be in +2 oxidation state because ammonia is neutral. And last case, 2 chlorine -2, so platinum is in +4 oxidation state. So our option is D. The compound CrH2O 6 times Cl3, and here we can see one chlorine went inside and one water molecule went outside. Second case, 2 chlorine atoms went inside and 2 water molecules. So this type of isomerism is known as hydrate isomerism. Then the crystal field splitting energy in tetrahedral crystal field delta T is equal to 4/9 delta O. Because we know in tetrahedral complex delta T is smaller than delta O. Trans CrCl2 OX twice 3 minus show optical isomerism. Trans compound cannot show optical isomerism. Optical isomerism is common in octahedral complexes involving didentate ligand. That's correct. So assertion wrong and reason correct. So our option is D. Next, EDTA is a hexadentate ligand. That's correct statement because EDTA we know it has 2 nitrogen as donor atom and also 4 oxygen as donor atoms. So here reason also correct. So assertion and reason both are correct statement, and reason is the correct explanation of assertion. So our option is A. Next, CONH3 5 times SO4Cl gives a white precipitate with silver nitrate. That's correct statement because chlorine is outside. When we add silver nitrate, white precipitate of silver chloride will be precipitated. So that's correct statement. The complex dissociates to give Cl minus and SO4 2 minus. That's wrong statement because sulfate is inside the square bracket, that will not ionize. Assertion correct and reason wrong. Our option is C. Low spin tetrahedral complexes are rarely observed because we know low spin complexes, the delta T values, crystal field splitting energy is very less, especially in tetrahedral complexes compared to the pairing energy. So assertion and reason both are correct, and reason is the correct explanation of assertion. EDTA is used to determine hardness of water. That's correct statement. EDTA is a bidentate ligand. That's wrong statement. It's a hexadentate ligand. So assertion correct and reason wrong. So our option is C.